Welcome to This Explainer. I am your host, the strategist, and today we are tackling the absolute ultimate challenge. We are going to engineer the perfect DNA of an A-star answer for Cambridge AS and A-level physics. We're focusing heavily on syllabus code 9702 today, but listen, if you're studying 0625, 0651, 0652, or 5054, do not go anywhere, because the core strategy remains exactly the same. Evidence plus analysis equals an A-star. That is the universal equation. We're not just here to casually review standard formulas or skim the surface. No, we're going to meticulously deconstruct the exact evidence and the precise analysis required to secure maximum marks. Think of this explainer as stepping directly into a high-tech lab. We are going to sequence the genetic makeup of a flawless, undeniable exam response.
So, let's dive right into this by looking at the massive stakes currently sitting on the table. 15%. I really want you to let that number sink in for a second. Did you know that the medical physics subtopic, and I'm talking specifically about the piezoelectric crystal and the generation and detection of ultrasound, accounts for approximately 15% of the total marks in Paper 2? That is a colossal chunk of your final grade, entirely wrapped up in a single highly conceptual area of the syllabus. We're talking about the difference between a B and an A-star right here in this one topic. If you miss the nuances here, if your answers are slightly vague, you are literally leaving a full letter grade on the table. We cannot let that happen.
To guarantee you secure that 15%, we need a systematic blueprint. Today's agenda is simple. First, the 15% mark. Second, core foundations. Third, the procedural framework. Fourth, examiner warnings. And finally, evaluating answers. Along the way, we'll be analyzing two very common types of flawed students. We've got Alex, who absolutely overloads answers with raw physics facts, but includes zero analysis. And then we have Sam, who constantly rushes and completely misses the command word requirements. We're going to make sure you don't make their mistakes.
Section 1, the 15% mark. Let's get right into why this matters so much.
Section 2, Core Theoretical Foundations. Here is where we look at the actual theoretical architecture of the exam itself.
Let's look closely at the architecture of how Cambridge actually grades you, because they target very distinct cognitive domains. You aren't just graded on basic knowledge. That's a huge misconception. You are graded on understanding, application, and analysis. You have to know not just what happens, but why it happens, and exactly how to mathematically prove it. Let's bring in our first student persona, Alex. Alex is a fact overloader. Notice the stark contrast between Alex's approach and that of top-tier A-star candidates. Alex relies entirely on isolated facts. If a question asks about a piezoelectric crystal, Alex will just write down, "It vibrates." Boom, done. But the principal examiner reports explicitly highlight that this is a totally flawed method. Candidates who achieve significantly higher marks do so because they reference cross-topic connections. They don't just say it vibrates. They link the alternating voltage directly to the mechanical resonance of the crystal. They connect core electrical principles with wave mechanics. They build a complete, connected, multidimensional picture.
And this brilliantly illustrates our next point, drawn directly from the official syllabus guidelines. It says, top-performing students exhibit connected, conceptual understanding, transferable to unfamiliar contexts. That word right there, transferable, is the golden key. The entire foundation of ultrasound and piezoelectric questions relies on your ability to transfer systematic analysis to completely new contexts. You might be given a medical scenario you have never, ever seen before in your textbook. Say they ask you to calculate the scanning of a specific, newly discovered type of tissue thickness. The examiner doesn't expect you to have memorized that tissue's density. They want to see if you can take your existing systematic analysis of wave reflection and acoustic impedance and apply it seamlessly to this completely unfamiliar situation.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 3, the Procedural Framework. It's time to shift into the assembly phase and fix some bad habits.
This is where we bring in our second student persona, Sam. Sam is the classic rusher. Sam looks at a complex physics question, panics about the time, and just starts writing equations. By doing this, Sam completely misses specific command word requirements, like failing to distinguish the crucial difference between state, describe, and explain. To cure Sam's rushing and to structure your answers perfectly, we use a standardized procedural sequence alongside the Peel framework. That's point, evidence, explanation, and link. Step 1. Deconstruct the question and decode those command words. Step 2. Extract the exact relevant data from the texts, graphs, or tables provided. Step 3. Select your analytical framework. This means clearly identifying the underlying physical principles at play before you touch a calculator.
Step 4. Execute your analysis with crystal clear mathematical notation and logical working. Step 5. Present your final answer using correct, highly precise medical physics terminology. If you follow these 5 steps, you are literally engineering an A-star response from the ground up.
Now, I need you to pay close attention to this, because this is an absolutely critical alert straight from the principal grading room. The examiners are actively, constantly, looking to award you marks for your process. They explicitly note that even if your final answer is dead wrong, method marks can save you. This is the ultimate safety net. If you follow the procedural framework we just laid out and you clearly write down your intermediate steps when, say, calculating ultrasound attenuation, you are catching free marks as you fall. Even if your finger slips on the calculator during the very last step, your beautifully structured evidence and explanation will secure the vast majority of the points.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4, Critical Examiner Warnings. We're moving into the quality control phase now.
Let's break down the top 3 examiner traps. These are the exact mistakes the principal examiners see ruining papers year after year. Trap number 1, confusing cause and effect. Trap number 2, forgetting format and presentation. Trap number 3, writing answers that are not specific to the context given. I want to zero in heavily on trap number 1 because it is notoriously, painfully common in medical physics. Students constantly, and I mean constantly, mix up the generation and detection of ultrasound. Listen closely. In generation, an applied alternating voltage causes the piezoelectric crystal to vibrate. But in detection, it's the returning mechanical ultrasound wave that causes the crystal to vibrate, which then produces an alternating electromotive force. Cause and effect, people. It is absolutely vital. If you reverse the sequence of events, your logic collapses and you lose all the marks for that question. Let's do a quick interactive workshop right now to cement this. I want you to imagine the exam question simply asks you to explain the detection of ultrasound. Now, think about our flawed students. The flawed answers from Alex or Sam will usually just state, the crystal vibrates and makes a voltage. That is incredibly weak. It lacks precision, it lacks context, and it totally ignores the PL framework. Now, look at the corrected A-star answer. It states, the incident ultrasound wave exerts a varying pressure on the piezoelectric crystal, causing it to vibrate. This mechanical stress generates an alternating EMF across the crystal, which is then processed as a signal. Do you see the massive difference there? The A-star answer uses the correct format, it uses precise terminology like incident ultrasound wave and alternating EMF, and it clearly outlines the precise cause and effect. It makes a point, provides evidence of the physical interaction, explains the resulting EMF, and links it back to the detection signal. That is how you get full marks.
Section 5, evaluating your answer. Because getting a number at the bottom of the page is not the end of the process.
This right here is the critical deconstruct, solve, evaluate, problem-solving loop. First, you deconstruct by identifying all the given information and command words. Then you solve systematically by breaking the physics into logical, methodical steps. And finally, and this is the part almost everyone skips, you evaluate by checking for reasonableness. Let me give you a reality check. If you calculate the acoustic impedance of human soft tissue and your final answer is a number larger than the density of a supermassive black hole, your evaluation step should trigger a massive alarm in your head. You need to stop, realize that number makes zero physical sense in a medical context, and go back to check your powers of 10 or your unit conversions. You must always justify your decisions and answers with grounded evidence. Let's formally define what this means, because this is how top-scoring candidates secure maximum marks. Evaluative thinking is defined as questioning assumptions, considering different perspectives, and justifying decisions with hard evidence. When you are presented with a complex ultrasound data table in the exam, are you just blindly accepting the numbers and plugging them into a formula? Are you taking a second to interpret the relationships? Are you recognizing the trend in attenuation? The examiner is fundamentally assessing your ability to pause, look at the data, and act like a real working physicist. So let's bring this whole system together. Here is the final blueprint for your physics answering strategy. Command words plus methodology plus evaluation. First, you decode the command words so you completely eliminate the temptation to rush like Sam. Second, you apply a strict systematic methodology using frameworks like Peel, so you don't just dump a messy pile of isolated facts onto the page like Alex. And finally, you evaluate your final result to ensure it aligns perfectly with the specific medical physics context provided in the question. Implementing these 3 rules is the ultimate guaranteed cure for those bad exam habits. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics in the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. I leave you with this final provocative question to think about. Are you just memorizing facts, or are you actively building the DNA of an A-star answer?